Okay, so I've got a customer, done a lot of radios for, and he just purchased this radio. So it's brand new, but it has been modified. This has I guess it's called an Asymod, is how it's pronounced. ASYMOD. Really not familiar with them, so, hey, I'm willing to give anything a shot, give it its fair, run through. Now, I will tell you, I'm not going to hook a microphone up to this because honestly, it's hard to do quantitative type measurements, really put something through its pace where you can test it with test equipment when you're using your voice. It's kind of hard. I want to see what frequency, the response, and whatnot, so I'm going to be using a signal generator to input signal into this radio, actually in sweep mode, so a sweep generator. So this was modified by I guess the Asymod guy. Now, I'm not affiliated with him in any way, and actually I went online because, I'd heard every once in a while you hear something, kind of off in the distance, you hear somebody say, Asymod, and you go, yeah, okay, whatever. It's another one of those things. So, anyhow, went online and did some research. Well, it doesn't take much getting, you really don't even need to get far into the first page of Google searches for Asymod to find out that apparently this board is, I don't want to say it's a counterfeit, but the guy basically stole the idea from Motor Mouth Mall. And there's some very convincing evidence of that. If you go online, I don't know if it was I think it was actually Motor Mouth Mall's website, I guess. He lays it out in detail. Some of basically his first, designs, I don't know, napkins, but, just scribbled on some paper, and he went through a lot of revisions. The man spent, honestly, a lot of time working this up. The whole idea behind these boards is that you increase your peak modulation, or your positive modulation, without increasing your negative modulation. Now, you don't want to increase your negatives, because once you get down to zero, in the waveform, which you'll see here momentarily, when you're looking at your modulation package on an oscilloscope, it goes up and it comes back down. And ideally, you just want it to kiss in the middle, just barely touch in the middle, and then come back up. So your positive peaks are at the top and bottom here, and then it pinches off to zero. You would never want to stay at zero, because zero is basically nothing. It's exactly that. It's nothing. So, but the idea behind these boards is to increase your peak, your positive peaks. Now, this radio has been modified. You can use either a stock microphone with it, not recommended, and apparently the Asymod website recommends not using a mic, a factory mic, because you're not going to get good audio quality. So what it has back actually behind my oscilloscope probe there's, and I have to give the guy credit, man. You talk about some shoehorning to get stuff in there, but done very neatly. He's got 2 more jacks installed in the back, in between the power socket and the external speaker and PA jacks under there. Crammed in between there is a 1/4-inch phone jack and a 1/8-inch jack. The 1/8-inch jack is for using with an external keying device, or in the case the customer that bought this radio actually got this from the guy. So it's a computer mouse. Kind of actually, I don't think I'd have thought about that. But yeah, it's just a computer mouse with a 1/4-inch jack on it. So yeah, you use this. Now, I'm a foot switch person, so if I was going to use this, I'd be using it with a foot switch. But yeah, it's just a switch wired up to that 1/8-inch jack, and then the 1/4-inch jack is actually your audio input. So ideally, and he explains that on the website, ideally you should be running a rack system, because if you use the mic jack on the front of the radio, your audio is being run through the radio, so it's already been processed, bandwidth narrowed, whatnot, and the whole idea behind these boards is to turn your radio into a broadband RF spectrum splatterbox, which is basically what it does. Now, I will say, on Spectrum Analyzer, I'm not talking broadband as in lots of harmonics. So I'm not talking about, there's a lot of harmonics out at 54 megahertz, your second harmonic. What I mean by broadband is it's transmitting broadband audio, good or bad. Honestly, the channel spacing of a CB radio, they're 10 kilohertz. So that's 10 kilohertz on either side of the carrier, okay? You honestly don't need any more bandwidth than that for fairly good audio quality. The problem is once you broadband a radio, truly broadband it, and you do what they call direct injected, which is what this does. So I have the, you can actually just get some of this stuff unhooked so you can see everything. So if you look down in there, you'll see it's kind of hard to see, but there's a big black jack under here. That's the 1/4 inch jack. There's an 1/8 inch jack over here. Has a little ceramic or yeah, the name escapes me at the moment. Yeah, it's the little capacitor. Oh, Christ, multi-layer capacitor. And what I have plugged in, we're going to be running, so I just have a BNC to 1/4 inch phone jack adapter. Okay, and this 1/4 inch, or the BNC cable then, runs up to, you follow up there, goes up to the signal generator. Okay, now the oscilloscope, we can follow that down, follow that probe down, which I just unhooked, and we'll get that hooked back up. So no sample ports, no nothing like that. We're going to hook the oscilloscope directly to the output. So there's no BS here. We're going to hook up straight to the RF output. All I got to do is get it clipped on there so it'll actually stay. Should have left it on there. Stay. So we have the oscilloscope hooked up directly at the RF output. And then I just have a Morse code key hooked up here to actually switch this in and out of transmit. Nice thing about this is it has the lockdown lever here, so I can just slide this lever over and that'll hold it in transmit. That way I don't have to use my hand because I'm lazy. So what do these little boards consist of? Well, when he bought this radio, he didn't just buy just the radio. He bought, like I said, he bought it installed in this. This is a Stryker, what the hell is this? SR-955HP. Now, it has a bunch of modifications done to it. Now, if you go on this guy's website, he does have a boat. I've got to give the guy credit. He has really documented this very well. The installation process for certain radios, he has everything you need to do. So all of these parts that are flying, you know, just kind of bodged on the top of the circuit board here, they're all parts of the modification. All these capacitors, there's parts down in here. So also wider, because of course if you're going to be transmitting wider, you also want to be able to receive wider audio as well. So apparently he also includes, I guess, new wider crystal filter, or the not crystal, ceramic filter. So the little black guy down here, little black cube, that 455 filter, that is a wider filter than what was initially in this radio. I, again, don't like stuff like that because when you widen the bandwidth of filters, you're just allowing more noise into your radio. Because instead of having a nice narrow window where you're hearing just what you want to hear but trying to block out everything else, this radio is now guaranteed basically to pick up adjacent channels. Because you've broadened the audio spectrum that it not only transmits, but also the audio spectrum that it receives. So the frequency spectrum. So, you know, if there's somebody on a channel right beside you, yeah, you're going to be, odds are you're going to hear them on this radio. Where before it was modified, it would have blocked it out like it should. But, hey, different strokes for different folks. I ain't going to fault nobody. I know lots of people like broadbanded audio. Have at it. You know, it's one of those things, it's whatever floats your boat. You know, a color that I like, you might not like, and vice versa. Color you think's fantastic, I might think is puke ugly. But, like I say, different strokes for different folks. There's a big community out there that likes broadband audio, and honestly, from what I've seen, this is a broadband radio, and it transmits, oh my God, does this thing ever broadband audio. So, let's actually do some testing here, actually show what we have. So, we have the signal generator up here set to sweep. Get the camera in a little bit closer so you can actually see it. So it's set from, so that's 1 0 with a decimal point. So from 10 hertz to 25 point, so that's kilohertz. So from 10 hertz to 25,000 hertz. So we're getting basically completely well outside of the human hearing range, even for an infant that has perfect hearing. Because the older you get, high frequencies, that's not a hearing loss or damage thing. It's just a natural process. The human body, as you age, you start to lose higher frequency, hearing. The older you get, the less higher frequencies you can hear. But 25,000 hertz is well outside of what anybody's going to be hearing. That's so high pitched. Yeah, might be great if you're a bat, but I don't think we'll be transmitting to bats. But actually, this thing probably will. And then we have our oscilloscope down here, which you saw is connected directly to the coax connector. And then we also have the spectrum analyzer hooked up. Now I have the span on this set to 50, matter of fact it's right there on the screen, 50 kilohertz. So 50 kilohertz is 5 channels. That's 5 channels worth, 5 CB channels worth of spacing. CB channels are 10 kilohertz each. So the center, the 10 kilohertz, was going to be one channel, and then there's 2 channels on either side. And I just knocked the oscilloscope probe off of the coax connector again. Get that hooked back up. Okay, it's on again. So that's, like I say, 5 channels. So what you want to see if you want a good working radio is you should see basically something in the right there in the center. But as the frequency is, you'll see the 2 side bands, because we're going to be transmitting in AM. And you have to remember, AM has 2 side bands. So you'll see those side bands actually move out, because we're using the signal generator up there. We're going to be sweeping from 10 hertz to 25,000 hertz over a period of 5 seconds. I have the sweep time set to 5 seconds. So you'll see those 2 side bands move out. Now with a 25,000 hertz maximum audio frequency, that'll come out just out to the outside edge, because we have the span set to 50,000 hertz. So 25,000, because there you have an upper and a lower sideband. So you'll see it sweep out. And like I say, that's for better or worse. That's more of a whatever floats your boat. If you want broadband audio, I can pretty much guarantee you this little module will do it for you. You'll probably be tickled pink with it. It probably, it's the cat's meow if you're into that. If you're like me, you want radios that are fairly narrowband. Narrowband radios, yes, you do lose some audio definition, the quality and tonal qualities. You're not. I always look at it this way: it's AM CB radio. You can only get so much fidelity out of an AM CB radio. You're not transmitting high fidelity FM stereo. So the whole thing I want to do is try and filter out noise. And that's why I want it narrow-banded, especially the receiver. I want that squished down as far as I can. There's a happy medium. You're going to reduce your audio bandwidth, but you don't want to reduce it to the point where you start to interfere with being able to hear somebody clearly and at least halfway, acceptable. But you want to block out the most amount of noise. So enough of me running my mouth. Let's key down and we'll turn on the sweep generator. So there's the carrier. You can see the carrier peak right here. And up on the oscilloscope, you can see that's our carrier power. And now I'm going to reach up here and enable the output. And I have it set, like I say, it's going to sweep for 5 seconds from 10 hertz to 25 kilohertz. And I have the output set to 800 millivolts or 0.8 volts. Because you have to remember, this is direct injected audio. We're not using the mic amplifiers inside the radio. Now there's amplification that happens on this Asymod board, but the actual microphone amplifier circuit in the radio, when you go in through this 1/4-inch jack on the back of the radio, you're bypassing that. So this is direct injected. So let's enable the output. So you can see, and that's what I really, like I say, for better or worse, it's whatever floats your boat, whatever you want. But what you can see is, so right here basically is going to be 10 kilohertz, one channel, but we have the span set to encompass 5 channels, and you can see those sidebands just keep going and going and going. So yeah, this thing will wipe out. It basically, any audio signal you put into this thing, it's going to transmit. And it doesn't care how far outside of human hearing it is. It's going to transmit. Because like I say, when you get out here to this far right or left-hand side of the edge on the screen of this spectrum analyzer, that's 25,000 hertz away from the carrier. Okay? So, and you can see we have, and actually I could even bump the audio up on this even more, because you can see there's still a fairly wide band there in the middle. So it's not actually reached even 100% modulation yet. So there I have it at 1 volt. Let me... But you can see, one thing you'll notice is how large that waveform is at the beginning at 10 hertz, when it starts out at 10 hertz, and the farther out you get in the frequency, or the higher the frequency gets, and you can also see that down here on the spectrum analyzer, it starts to drop off. So, you know, it does ramp off. It's not a continuous power level. You can see the amplitude dropping as it sweeps through that frequency. But, so that's what it does. Now, like I say, I'm going to have to say, you know, if you're into that type of thing, this does it. And it does it well. I was cramming, at that point right there, I was cramming 1 volt peak to peak in through that 1/4 inch jack on the back, the audio jack. So, it works. There's no ifs, ands, or buts about it. It does what it's supposed to do. Now, like I say, this one was, I haven't done anything to it other than remove the covers, basically, and hook up this oscilloscope probe. I haven't touched anything, and I'm not going to do anything to it, because the Asymod guy that built this for him has already done, apparently already set this up. Now, you will need to, so this is basically for the owner, which he describes on his website, how, because you're going to need to set this up, the audio, specifically for the rack. You got to remember, this isn't meant to be hooked up to a signal generator. It's meant to be hooked up to a microphone through a rack system, or, you know, just a basic EQ would work. But you're going to need to fine-tune this a little bit, and he covers that on his website through the instructions. But, yeah, so, I mean, opinion, there's thumbs down and thumbs up. It depends on, I guess, what you'd ask me. Originality, thumbs down. The idea was clearly and obviously stolen from somebody else. And basically stole the other guy's glory. Motor Mouth Malls. So, yeah, thumbs down for that. Does it work? Yeah, I'd honestly say it does what it's supposed to do. So, thumbs up. It broadbands your audio, greatly increases your peak positive modulations. So, yep, it works in that respect. The board, good quality. You know, it could be better, especially like the electrolytic caps. I'd probably use a little bit better quality there. And before I forget, something I just had to show, because that board, and this is the other board that he ordered, because he ordered a second one, because he said if he liked it, he might install this in one of these in another radio. He might want to tinker around with that himself. Do you notice something kind of out of the ordinary? The ICs have the numbers rubbed off, because he thinks we're idiots and we can't figure out what ICs he has in here. Well, I mean, it's kind of obvious with what this module does, how it works, that they're just op amps, but we can actually show exactly what they are. So it was however long ago I did it. I did a review on these cheap little Chinese IC testers, which are also IC identifiers. So we're going to turn this little guy on, self-check pass. We're going to grab our little cheapy IC pullers here. We're going to pop the IC out of the socket, drop it into the test fixture, hit enter, and I almost bet you it's going to say LM324. Yep. LM324. And the other ones should be the exact same thing. So we'll take this one out, put it back in its socket there. I will say he did use good sockets. They're not the cheapest thing you can get off the Shenzhen market in China. They're actually good, the high quality machine pins. So you can see there, it's not just the little springy finger kinds. They're actually good quality sockets. So like I said, I give the guy credit. He's got some good quality parts on there. And actually we'll just start over again. I'll turn this off, turn it back on. Oh, got to hit enter. And it's going to come up with that error code because there's an IC in it. I didn't let it do its self-test. But I hit enter again, and you can see LM324. So, yeah. So, okay, the cat's out of the bag. I just revealed what his secret ICs are. Yeah, they ain't nothing special. They're just LM324s. And honestly, if you have a Radio Shack still in your town, you can probably get LM324s at Radio Shack. Now this is a DC to DC converter board here. This, it looks like he actually buys these boards. I gotta lift it up here to my face. I think somewhere on here. I was thinking, maybe not. Maybe that was somewhere on his website. I think I saw on his website, or I saw a picture somewhere of another one of these where it had a logo on here. I get the feeling he buys these DC to DC converter boards, because it's actually, as you can see, there's a circuit board. Try and get the camera to focus just on this. There's a circuit board sitting on top of the main board. It's a lot thinner, but this DC to DC converter board is actually sitting on the main board, and it's just, he has some basically wires through some pass-through holes around it, for the main connections on that DC to DC converter board. But I think this runs, because this actually runs off of, I think it's 24 volts for the transistors. So that's why it has this converter board, because of course the radio's only going to have 13.8 volts going into it. So, but there it is. Like I say, I guess if this is your thing, I'm going to say you'd probably be happy with it. Now, me personally, I'd never buy one. Because it was a stolen idea. I think that's a crock of hoo-ha, doing stuff like that, stealing somebody's idea. It's not so much just the stealing somebody else's idea, it's stealing the other guy's idea and taking credit for it. If you went to Asymod's website and he said right along the top of the page, this board brought to you by the generous help of Motormouth Mall, I'd be all for the guy then. But yeah, just to blatantly, more or less say, I invented this myself is a bunch of bullshit. So, like I say, that kind of turns me off. But there you go. There's my honest opinion. You've seen that, yes, it will definitely broadband your radio. Like I say, I think the people that are into broadbanded audio would probably be very happy with these. But like I say, if you're like me, yeah, you're never going to install one in one of your own radios. You'll never see one of these in my radios. And yes, I will say it now to save myself from getting questions. Don't bother asking me. No, I will not install one of these either. So, yeah, don't bother asking. If you want one installed, I guess contact the guy that makes them, the Asymod guy, because he obviously installs them. Matter of fact, you can buy brand new radios from him with them already in. So, and honestly, if you want to use one, that's probably the best route to go, honestly, if you think about it. You get one of these new Strykers. I think the Strykers are probably one of the better export radios out there nowadays. Or import, like I say, depends how you look at it. Just, they're being imported into the U.S. It's not like they're made in the United States and exported. They're being made in China and imported into this country. Stryker may be a U.S. company, but yeah, they're being imported. But that'd probably be the best way to go if you really want one of these, is just buy one of these guys' radios that already has it in there. Like I say again, that's something you'll never see me do, because stolen idea, the guys taking the other guys, taking credit for the other guy's work. But there you go. So, actually, I guess one other thing we could do, I forgot I had the old walkie-talkie sitting here. So we could actually just, you could hear, now you can only hear so much coming through this little guy, because you have to realize this is not modified for broadband audio. And the sweep that I had that signal generator set to, like I say, gets well out of human hearing range. So you're only going to be able to hear so much. But let's turn it back on. So the radio's now on. I'll turn my walkie-talkie on here. Key the radio. So that's just the carrier. Now I'm going to turn on the output from the signal generator. So you can watch as it's doing it. So you can see all of that extra crap that's getting out there. It gets to a point where it's useless. Why is it broadbanded that far? You can't hear it. You get to right about there. You've reached the limit of human hearing. Yet it's still transmitting, I mean, hell, and I could go out even farther. So actually, let's turn that off. I'm going to change the... let's get into sweep. Stop frequency. I've got it at 25 kilohertz now. Let's set that to, oh, hell, I don't know, 35 kilohertz. Why not? 35,000, okay, hertz. Ah, hell, I had that set to span. 35, 1, 2, 3 hertz. So we're starting at 1, actually, I don't want that far. Start 10 hertz. So we're sweeping from 10 hertz, and I'm going to have to change my spectrum analyzer range here now. So let's just make it 100 kilohertz. Yeah. And you can see it's definitely dropping off the farther out we get there. But yeah, man, that's that's a crock. This thing's transmitting out to 35,000 hertz. So far out the human hearing range is to be funny. Turn the volume back up on my little screen. And you can hear how long it's quiet. You can't hear anything. That's because it's unaudible. Yeah. So turn the output back off and unkey the radio. So there you go. Yeah, this thing, hell, it'll sweep out to 35,000 hertz. So it has one hell of an audio range, man. Yeah, I guess if you want to talk to bats, man, this would be the radio to have, because this thing's getting into the really high frequencies. So there you go. Just my opinions on the Asymod installed in a Stryker SR-955HP. Yeah, we're giving away some of those trade secrets, so just remember those ICs. If you have one of these, you ever have problems, you take it to your radio tech. Everything on this board should be easy to diagnose. If they don't know what the ICs are, just tell your radio tech that they're nothing more than common LM324s. So, and hell, he'll probably have those in stock. So there you go.